Hi everyone, in this video we're going to look at how do we add a memory to the AI agents. So we will look at one of the most popular solution, which is the Mem0, is an open source library. We will be using that library and integrate that library with the LangGraph. So that's what we're gonna cover in this video. If you would like to know the step by step, so this is what we would be covering. So we will go with the Mem0 basics. Basically, how do we add those, update those, and search those memories explicitly, and then we will take those concepts and integrate with the LangGraph. And I will also show you how do we customize this Mem0. Let's say we would like to use our own vector DB. So I'm gonna give you an example of how do we integrate Qdrant with the Mem0 so that Mem0 uses Qdrant for those memories. And I will also show you the Mem0 cloud platform. So if you don't want to use the local version, you can basically use their cloud platform because it has a good UI, where you could basically check all the memories, and you can look at those memories and how those memories were the form. So we will also look at that particular thing. So let's go step by step. The first thing, let's talk about the Mem0 basics. So first, I would like to set some keys for me since I will be using OpenAI key. Basically, the Mem0 internally requires some LLM to extract the facts or some information from your conversation. So we will definitely require some LLM, and for the LangGraph also, I'm going to use the OpenAI as an example. You could use any other model, whatever the access you got. So I'm gonna get that value from the Google secret. So if you are not aware of this thing, you can put your all the keys here. Basically you can add a secret with the key and its value, and then basically you can access with that name. That's what I'm doing. I have already added. You could add the new one also if you want. So this is how I'm accessing the user data dot get the name of the my key, and I'm able to access all the key. This is how we will access all other keys that we're gonna require. So we got the key, OpenAI key. We also required the Mem0, as I told you. You could install this library. So let's install this library and import that object. Okay. Okay, so we have imported the Mem0 from the memory, and this is how we could use it. So basically we could directly use it as a memory, but then what I found, if I directly try to add you know memory to this particular initialization memory, then we get some error. So we get this error, that you can't write to the readable database. The reason being, I think we were not using any DB for it. So what we will be doing now, we could also pass a configuration to the memory when you create the memory object. So this is what we're gonna do. So we're gonna say that, look, here is my DB that you should be using. So we are specifying the history.db. It will be an SQLite DB that it will be creating, and this config is important. This is how you can specify its or let's say overwrite its default configuration. So basically config is a dictionary that takes a lot of things. So here, this is how you can even pass that I want to use, let's say, particular LLM provider and its model configuration. So let's first only use this one, which is that I want to use this particular path as a DB, and you could see we got the DB here. So we got the memory object, and now we can play with that memory object. The first thing, the simple thing is, let's add memories to the memory. So basically how it works, so you could add the messages. Now you know that whether you use LangGraph, LangChain, or any other library, right, they all follow the ChatGPT kind of format, where you got each message like this, and that message has two things. One is the role, basically, which indicate from where this message came, whether it came from the user or whether it came from the assistant, which is an AI, and what is the content of the message. So this Mem0 library also support the same syntax. So you could basically pass the list of messages to this memory object using its add method, and you can also pass an identifier because you want to associate these memories with some kind of a user. So we have to put a user ID. So I'm going to use, let's say, user ID Pradip, and I'm going to pass some messages, and I want to see what kind of facts or what kind of memories it is able to extract. So I'm going to say here, let's say my name is Pradip Nichite. I run FutureSmart AI, and I built a, let's say, custom AI solution. So I'm going to just run this thing, and you could also see the second example. Here we could add a messages to the memory and also specify some metadata. Here I'm saying category as a preference, so it could have any key value. Okay, you don't have to use it. So here, since I say that I love building RAG and AI agent application, this means like it's like a preference is what I have, and that's the reason I put this way. So let's run this one. Okay, so when you run, as I told you, it's going to use LLM under the hood, and basically find the memories for it. So we got so this is the output of the last statement here. This is how when it adds the memory, you get the back results, and each memory will have an ID that you could use to again manipulate it. And this is the memory that is, it is extracted from this particular message, that he loves building the RAG agent and all this thing, and these all memories are associated with this particular user called Pradeep. Now this is about adding the memory. Then how do we search those memories? Now if I search, let's say, what I like to build, and I'm passing that user ID to the search method, it will use semantic search and compare it with all the memories what I got. So let's look at what relatable memories we got. So we got couple of memories here. Even though we had just two messages, those two messages are actually, let's say, broken down into multiple memories. So maybe just for a curiosity, we can check what are those memories we got. So the first, when I search semantically what I like to build, the relevant memory, it has something called, the Pradeep builds a custom AI solution. Okay, then this is the one memory object. This is one memory. What is the other memory here? It says that he's love building RAG and AI agent solution. What is the other memory we have? It says that Pradeep runs FutureSmart AI. What about the other one? This one, he says his name is Pradeep Nichite. So basically you saw this, right? These four messages got broke into four different memories, and the relevant memory, let's say if I say, I also say some score associated with 0.39, 0.38. I guess this is the most matching one. When I ask what I like to build, it says that it likes to build a custom AI solution. Maybe I change and I say, okay, who I am, and now let's say which one gets the more matching. So when I ask who am I, the memory related to the my name is actually getting the the highest score compared to the other one. So these are just relative score, okay, but you could see the highest one is related to the name. That's how these memories work. So when you have thousands of memories for that particular user, it will try to find the most meaningful semantically matching memory for that particular user. Okay, so we just saw how do we search those memories, right? And then we can also see all the memories associated with that user. Currently we have only these four. That's the reason we see these four memories. And you can also take any of this memory. Let's say I pick up this one, and you can get that specific memory. So you can use the get method and get that specific memory. What happened? We are not getting the memory or what? So we got the memory ID. What is this value? Let me see why it's not printing. It says none, so it is not able to find the memory. Did I copy correctly? Oh, I copied hash instead of ID, so I should have copied the ID. So let's copy the ID. Okay, now we see this is the memory associated with that ID, which is builds custom AI solution. Now let's update that memory. So instead of saying builds custom, I say build custom Gen AI solutions instead of let's say only AI solutions. And I'm going to use the update method. I'm going to pass the memory ID that I want to update and the data that I want to update with. So let's see. Okay, it is saying that the memory updated successfully. Should we verify this? We can again run this thing and let's see whether the latest memory is getting yes, the latest, which is Gen AI, is actually getting reflected compared to what we had old, which was just, let's say, AI solutions. Okay, but there is also a way to know basically what are all the history of that particular memory. So here we should be able to see for every memory, it also track what is its old memory. So this was our first memory, which is the build custom AI solution for that particular memory ID, and there were no earlier any memory. But now we got some. If I look at the next memory associated with that same ID, which is the latest one, this one is the latest one. That you could see the old memory was building custom AI solutions. The new one is actually the building Gen AI solution. Okay, so we just saw all the basic stuff. At the moment, we look at adding, updating, and searching those memories. Now is the real part. How do we integrate that memory so that it can be used by an AI agent? That's what we're gonna see. So we're gonna create some simple LangGraph agent. So let's go there. Where it is? Okay, yeah. So before that, I just adding the the langsmith tracking. You might have seen in every video I add, because I would like to see what's happening under the hood. So I'm just adding that tracking. If you don't want, you don't need to add it. And meanwhile, if you want to learn, let's say, the LangGraph agent, how to build the LangGraph agent from very basic to the advanced, that which we have already covered in this recent tutorial, that you can go and check. So I'm just gonna use a small snippet from this tutorial which I will be explaining, just for the sake of this particular tutorial. But I will urge you go and watch this tutorial, because here I cover from basic to advanced. Now, yeah, so basically in the line graph, what we want, so we want to declare a state. I will be going to these imports as I am going to require them. So basically, require state. State is nothing but it is a information or data structure that is shared among the LangGraph nodes. So if you're not familiar with the LangGraph node, let me show you one diagram. So this is what a typical LangGraph agent will look like. So there are different nodes. So here is a router node which decides where to forward the request. Then there is a, let's say, a dedicated node for the RAG. There is a dedicated row to do the web search, and there is a node to generate the answer. Now these are the couple of nodes, and when you start the conversation with an agent in a particular request, we need to pass some information to, let's say, the router wants to forward that request to the answer node. It needs to pass some information, and that information is nothing but the state of that LangGraph agent, and that state is nothing but a Python dictionary. Here, let's say it is a Python dictionary. So what we're going to pass throughout the each agent. Okay, let me tell you, I'm not going to cover this in this particular video. It is to just to show you an example. If you want to learn this, go here and then you will learn. In this particular example, I'm going to use a very simple LangGraph agent. So in this example, the state going to have the messages. Definitely we want to pass those messages among those nodes, and the Mem0 user ID, because we know that we need some kind of an identifier to retrieve those memories associated with the user. And then we just declare here the graph. We are just declaring, not building, it's just declaration. And then we also import from the LangChain OpenAI chat OpenAI, because I'm going to use the GPT-4.1 mini inside my chatbot node, or let's say LangGraph agent. Next thing, once we declare the state in the agent, is basically node. Node is basically this one. This one thing is the node. Now what we just going to declare one node, which is a chatbot node. This is the node which will take a state and then it will process it. If it is not this complicated, this is how the simplest node looks like in the LangGraph, which we have seen in the previous tutorial. So this particular chatbot node simply take the state and invoke the LLM and return the response. That's it. Taking the messages, invoking it, and giving back the response. But here we want to do something extra, because we want to retrieve the relevant memories with respect to user query, and that's what we're gonna see here. So let's look at, whenever the state comes to this chatbot node, what all things are happening. The first thing, let's say we are retrieving the messages and this user ID. Now we want to see, do we have any memories associated with that user? So we're going to use the memory.search. And if you look at what we are using to search the memories, since this messages has all the messages throughout the the LangGraph execution, we only care about the last message, because the last message is the user message that we gonna send. Again, if you already watched my previous video, you know exactly this is the last message has user query, and then we're gonna pass the user query and the user ID, so that we get the matching memories. We are also printing those memories so that we can check. Now since we got the memories, okay, then we want to build our context. So we are saying that these are the relevant information from the previous conversation. So here is the interesting thing. A lot of people get confused between the memory and the chat history. See, chat history usually used for one single session, one conversation. Okay. Again, I have also explained, that tutorial, or the LangGraph tutorial, how to, create the session. I also created the second part that you can go and, basically check. So if you're not sure, let me show you the second part that which I have created, that covers everything from let's say the session management. So the latest video that I had created, which took that LangGraph agent and then basically integrate with the fast API, shows you how to manage the session and the conversation or the chat history. So you should go and check if you want to become an engineer who can build this production level system and not just collab tutorial. So go and check here. Here, the memory is across the conversations. The memory is not related to any particular conversation ID. It is at a much higher level. It is at a user level, and user can have the multiple conversation. So memory and the chat history can go together. Okay. So chat history just talks about the recent conversation, what is happening. The memory could be any past conversation, some important information that we have extracted. I hope it's clear now. And we're gonna just search those relevant memories and gonna put inside the prompt, saying that while answering, these are some relevant information from the previous conversations that we have about the user. We will see in the langsmith once we run this thing. And then our typical system message, we're going to get those our basically we got this message, and the newly system message that we created, we're going to pass all these messages through the LLM. It's just the same thing that the typical LangGraph node does, and eventually we're gonna return this thing response. But before returning, we want to make sure we update the memory. So to update the memory, that we have two messages now. One is the user message, which is this one, user content, and we also got response from the agent. So we're going to add both of these messages to the memory for this particular user and let the mem0 decide what to extract from it. Okay, I hopefully though I hope this is clear to you. Even if you didn't watch my previous video, I think we need to declare the state. Okay, I didn't execute them, so let's do one two. Okay, we declared the state, we declared this node function. Now it's time to build our graph. Okay, am I declaring again state graph here? Let me just check. Yeah, it is just we might not need this here. We just declare it here, and then basically, yeah, we're gonna get that state here, graph builder. We're going to add the node. We got only one node, and then we are saying that our starting age. So basically, whenever the user query come, it will first go to the chatbot, and from chatbot it will go to simply end. So the start and end are special nodes from the LangGraph. So very pretty simple, like there's nothing much we could uh, do with this particular agent. But this is to just show you that how this one single node, a chatbot node, can utilize the memories stored in the mem0. Okay, don't forget that I'm going to also show you how to use the mem0 platform, because I like the UI that they offer to interact with the memories. So you might want to stay till the end so that we can look at them. Okay, so what we will do, we will just create one utility function called run conversation. Its job is simple. It will take the user query and the user ID, create our the state, because we know that our state requires what, two things. Our state require messages and the user memory ID, and we just did that same thing here, that we take this user ID and the state messages and create the state. And we do same thing, we simply invoke our graph just like we're going to invoke any particular node, and we will get the result back. We will get its content field, which is the actual response, and we're going to just print it for us to see what's happening. And I'm just going to run that function in the while loop so that we can have the conversation. So let's do now. So I'm using the memory as a customer Pradeep. Let's see, and I'm saying, hi, I am Pradeep. Okay, so when the first message went there, there were no previous memories associated with the Pradeep. And let's say, okay, I am a founder of FutureSmart AI. Now you see there are some memories associated with the Pradeep that came. Now I will say maybe do you know me? Okay, it says that, okay, I remember you. You are the Pradeep and founder of FutureSmart AI. Now you might say that, okay, what is big deal? Even with the memory, the LangGraph memory, we are able to remember this thing. But as I told you, this is not about one conversation. It should be returning across the conversation. So I'm gonna stop this conversation. Okay, I'm gonna rerun now conversation. So this is a different conversation now, and I'm going to directly ask who I am. See, it is able to remember me. That's the difference. The earlier video which I had covered here we are able to only retrieve the chat history of the current conversation. But with the memory, now we are able to not just retrieving the current conversation, but we are also able to retrieve the memory which was stored across all the conversations. That is what the thing. So let's also look at the Langsmith, maybe what we see there. Okay, so when I ask who am I, let's see what was happening there. If I go to the chatbot node, so this is the chatbot node, and this was the relevant information that was dynamically put, which is the name is Pradeep and is the founder of the FutureSmart AI. So this is what it extracted from my previous conversation. That's how the memory gets inserted. Now let's look at what is the next thing we could do. Okay, we saw this thing, but where is this memories get stored? I guess they're stored here. This is what my understanding. They are in this history.db. And I'm not sure, like I tried checking what is their default, but seems to be it's all in the SQL DB. But what if we want to use our own, let's say a vector DB, like let's say I mostly nowadays using the Qudrant, and I want to use a, let's say, quadrant cluster which I see, let's say, and this is a free cluster which I created. Up to 1 GB you can create. I think for practice I created this one. Let's delete this one. What about this? This is also during the practice, so let's create, delete both of these things. So you can go to the Qdrant Cloud and you can get the free cluster, up to 1 GB, and that is enough for a lot of small projects. So I'm going to use that one. So before that, so you can create. So if you go to the Quadrant, you can create your cluster. So this is my free cluster, you could see, and you will get some detail like endpoint detail. You can also generate your API keys from the Quadrant that you can use it. Now I will show you how I'm using. So first thing, let's install the Qdrant client. And to connect the Qdrant client, we require the URL and the port number, which you should be getting from here. So I hope we got that information here somewhere. So URL is this one. This is the URL, and I think by default it runs on that port. Logs, metrics, backup. Yes, so by default it runs on that port. This is the URL. Do we have any sample snippet or code here? How did I? Okay, let's not waste the time because I got the code. So yeah, so basically I'm going to get this particular endpoint URL, and we're going to, okay, here is an example. Use the API. I'm just checking where's an example. Yes, so if I go to the Python, this is what the example you can get, right? So you know that you have to hit the 6333, and this is an API key. So I just copied this same one, which is here, and again I stored that key here in this collab secret. Let's see what collections we have. I think we will not have anything. We just deleted, so there is no collections at the moment in the Quadrant. And let's do one thing now. We can show you how do we integrate. So if you go to the Quadrant, sorry, Mem0 and Quadrant integration, you will see we have to pass this config like this to use the vector DB. So here we are saying I want to use vector store of Quadrant, and this is the configuration detail of the particular Quadrant. But this documentation is not enough, and I got the error. That is the reason I need to make some changes. I will show you what I got the error. So let's try what they are saying. So this is our Quadrant host. This is the port. This is the Quadrant key, and we also have that similar config. I give the collection name as a mem0 yt, and it's the same step, which is like constructing the memory from this config, and I'm going to pass this to let's say the messages through it. Let's see what happens. Okay, you saw we got some error. So this documentation is not sufficient. So we got error saying that some index is missing. Since we are storing this as a metadata with the user ID, it is expecting there should be an index on the user ID, but there is no index, and there is no steps even in the Quadrant to, sorry, Mem0 documentation, that I need to create that index or something like that. So what we need to do for that particular thing is to create the index. So this is to create the collection. Yeah, here is the step. So you need to create the Quadrant client, create the payload index, and basically give the name of the collection, the field we are using user ID, and this is the type of the field schema called keyword. So maybe let's see if I could show you by searching. Means you can go and read the documentation of the Quadrant. I'm using Quadrant for a long time, so kind of familiar with it basically. So do we have a create index or something? So there are different ways that you can create the index, and we have to define whether it's a keyword, it is an integer, but this is our keyword index that's we're gonna use. So let's run this thing. That, so it completed, because even though this got failed, but actually collection was created. I could show you that the collection was created. Yeah, so the collection was created, only it failed insertion. So there should not be any record. Let's check whether there is any record. So if we go to Quadrant, yeah, so this is the default one they create, but this is the one where we're going to put our data, and you could see there is no points, so there is no data at the moment because data insertion got failed, but it does got created. So let's try again insertion, and hopefully this time our data, these two records should go there. Yes, so how many memories it inserted? One, two, three, four. Four memories got inserted here. Let's see whether we see the four records or we see. Okay, so we do see the four points has been inserted, because we know there were actually the four the points. Okay, so we saw the how do we customize this mem0 with the, let's say, the using the Qdrant Vector database. And again, these all configurations are available if you go to their website. So let's like, if you look at for LLMs, there are, let's say, supported LLMs, and if you go to the Anthropic, you will see what should we be using for the Anthropic. So you got all these details available on the mem0, so that you can try. Okay, so let me go back quickly here. So we tried the basics, LangGraph integration, and the vector DB setup. Now, next thing we will try is, let's look at their cloud platform. What if you want to use their cloud platform? So if you go to the mem0 platform, this is their platform, and basically, you can generate your API key. I already generated one API key. You can generate the API key, and once you got the API key, you could use this platform. Okay, so let's go there, because I got the API key already. Yeah, here it is. So from mem0, I'm using the memory client, and I can pass my API key. Again, it is stored here in this script. So let's initiate the their cloud platform client. Looks like my collab got disconnected. Okay, it got run. Now it works similarly what we just did earlier. The only difference is it going to save our data on cloud. It is saying output format is deprecated. Okay, whatever that, let's look at whether this data is got stored or not. Let me read again, because if I miss anything, some documentation, I think something got, the create memories has got changed. So what has got changed? I still see the create memories the same way. Initialize client, yes, I think this is the same, their client. What it does, client dot add, it's the same thing, right? Role user messages, I don't see any difference. So what is difference in our work? We got the role user message content. Is it content? Yes. I don't see there's anything much change. But did we got this memories inserted? We can check. So I give the name to the founder, but I might have given earlier this name. So maybe I can try Pradip YouTube as a user ID and then try. Okay, so this got inserted here. We got some output. Let's go to the platform and check whether we see this user is coming here. Let's refresh their platform. This is what the Pradeep YT, the one that I just inserted. Let's look at for this user what they got. So I see there are two memories associated with the user. The one is that he's a founder of FutureSmart AI. Let's look at what they are doing basically. So when I say I am the founder, they are kind of rephrasing, basically extracting the facts from it, and that putting in the platform, that is it. And they, you can also see the source of that information, which is this message which we added. Here's another memory, which is we can check what happened. You can go to the details. Yes, the username is Pradeep, and again it's a source. Why the source is not sure, why it's not refreshing, but if I look at the details, the username is a Pradeep. That is what it is extracted. So let's go back to yeah, because there is only one single message. Okay, got it. Because there is only one single user message. From that message, two memories created, which is the name of the user and what they, let's say, do or something like that. Now I got one more thing here, that yeah, we could also add the metadata. If you add the metadata, this is how it will look. Let's say if I give some username to this. Okay, I have already used Alice123. Let me use this, let's say Alice YT, and we go and check what happens now for that user. Again, we can go back to the user's dashboard. This is the Alice YT that we just see, and there is a memory, only one memory. Why? So there is only one memory. Watching movie tonight, messages. Okay, there are two user messages, but I see there is only one user memory. Maybe it's not refreshed. We can again check whether it's really only one memory. Yes, it's only one memory. And what it says, prefers the sci-fi movies or the thriller movies. Prefer the sci-fi. Okay, this one. And I am planning to watch movie tonight. So basically, this it didn't consider remembering that it's going to watch movie tonight. Rather, it extracted the fact that Alice prefers, sci-fi, I guess, compared to the other one. And we also see the metadata that is coming here. The metadata that is added, it's also coming here. So this gives you the nice UI. If you are interested, you can use their, platform. They also got something called graph memory, which I'm thinking to cover in the next video, because they were kind enough to give me the access to the graph memory because it was costly. So I'm gonna show you that how to add a graph memory to the agent maybe in the next video, because this video already got longer. Now, yeah, we just saw how do we add the platform. There is one more thing. Okay, you saw that every time we add the message, it saves two things. It saves the source, which is actual messages, but it also shows stores a memory, which is some kind of a inference from that messages. This memory is not exactly equal to the, let's say, the actual message. It actually inferences something from it. So it is like a rephrasing inference, but you can off it. What if you just want to, basically you don't want to infer anything, you just want to put the real user message as a memories, and that is also you could do. So let me try show you that if I execute this for this user 1235 and I go back to the user dashboard, this one we just added. Okay, so you see there are actually two memories, but those two memories are exactly what it is said in the message, which is, I'm not a big fan of this one, right? Exactly same, but I love sci-fis, because there is no inference. You are just saving whatever, and if you want that, you could do that thing. So this is what the flexibility that mem0 gives you. You could actually use their inference, which will use LLM, and then infer the memory from it, or you could directly use the actual user message as some kind of a memory in the future. But I guess if you start using the actual user message, it might get bigger, because you just saw these two messages actually have just single memory. But if you disable the inference, you got two messages. So imagine over the period of time you will have so many user messages. That is not possible. Then it defeats the purpose of the memory. Memory should be something that you think important and which is extracted. I hope you found this video useful. Let me know if you need some kind of an extension of this particular tutorial. Okay, because as I said that I will be creating the video on the graph memory, and I'm going to take the example of the mem0, the graph memory, which is here. Yeah, mem0 graph memory. This is what I will be covering in the next. Okay, there is nothing for this user, that's why, because we haven't used anything for the graph memory yet, and I will be covering in the next video. Okay, hopefully you like the video. If you want to try the agent, you can go and try on the agent.futuresmart .ai. There we got the agent that you can try yourself and give us the feedback, and let me know if you have any suggestions for the next video. Thank you.